everybody, Miss Saltstein here. So this lesson is all about proportional relationships in graphs and a little bit about tables. There's only a few things that you really need to know about this, okay? If you have a proportional relationship, okay, and that's the relationship of like water to rice when you're making rice, okay? Anytime you make rice, you want to put 2 cups of water for every 1 cup of rice, right? If you're going to have 3 cups of rice, you're going to have 6 cups of water. Otherwise, the rice gets all gummy and gross or it gets crunchy, okay? That's a proportional relationship. So, if you have a proportional relationship, it is going to make a graph of a line, like this one that I'm highlighting over here. It will go through the origin, 0, 0. Okay? So that's something you need to know. Okay? If it doesn't go through the origin, it's not a proportional relationship. It's, first batch of rice is good, second one's gummy, that kind of thing. The other thing you need to know is that you can look at the graph to find the unit rate. So that's cool. Remember unit rate per 1. So you just go to 1 on the x-axis and then go up to the line, and that's your unit rate. Okay, when you're looking at a table, okay, let me get a different color for that. Green on green is not so good there. Okay, so if you look at the table, you can find the unit rate where x is 1. Okay, and if you make fractions of y over x, they will always simplify to equal the unit rate. Okay, so 3 over 1 equals 12 over 4. If you simplify 12 over 4, you get 3 over 1. That equals 21 over 7. Right, divide those both by 7, you get 3 over 1. And that equals 30 over 10. The other thing that you need to remember is that the graph of a proportional relationship will always make a nice straight line. Okay, and I love what Miss Angel said about the origin looking like a little owl, 0, 0. I think it does. I'd never seen that before. All right. The constant of proportionality is a really fancy word for the unit rate. And again, it's that idea of y over x being the same constant for any point in the graph. Okay, so this here, all these fractions being equal, that's what we mean by a constant of proportionality. Y over x is constantly equal to the unit rate. Let's look at some of the problems here. Oh, so keywords first. Keywords, linear. Okay, that's this, the straight line. Okay, so characteristics of proportional relationship graphs is that they are linear. See, the word line is right there in the word linear. The origin is that point 0, 0, the owl. Okay. Where the x and y axis cross. Proportional. Two quantities are proportional if their ratios are equivalent, and that's what we did right here. Okay. Ratio is a comparison between the relative amounts of two quantities, and we are comparing y to x. Okay. The y-intercept is the point of the graph where the line intersects the y-axis, and then the x-intercept, we don't need the x-intercept. Pretend I didn't say that. All right, so this is one of your quick check problems here. We are looking for a graph that meets all of these characteristics. We want a graph of a proportional relationship. So I'm looking for a straight line. It needs to pass through the origin, and that is this one. Yes, the line is straight, and it is passing through the origin right there. All right. Someone's trying to call me. Call him back later. You're more important. Okay, let's look at some more problems here. This one says, What is the average number of heartbeats per second? Okay, so guys, here when it says per second, that they're talking about the unit rate, okay? So per second means per 1 second, and that's the unit rate. I'm going to try to make this a little bigger so you can see that better. Here we go. What is the average number of heartbeats per second? There are a few ways we can do this, okay? We can definitely find 1 on the x-axis and then go up to the line. It's about there. The only problem is it's really kind of hard to figure out how high up that is on the graph, okay? And so these are the number of seconds, and then these are the heartbeats. So if I look at the unit rate at 1 for the number of seconds, it's kind of hard to tell. So here's what I'm going to do instead. I'm going to look at one of these points on the graph, and I'm going to pick this one over the other one because it's like perfectly on the, right in the crosshairs there. So what I would say here is that this point represents 6 beats per 4 seconds. Okay, that's my rate. It's 6 over 4. To find the unit rate, I'm going to do what I did a while ago in my lessons a few days ago. I'm going to divide by the denominator. 6 divided by 4 you could do in a calculator. I'm just going to do it here long division style, just to slow things down a little bit, make sure you're understanding what I'm doing. So while I'm doing this, your brain can be trying to remember, what's a unit rate? Oh yeah, it's the rate per 1 of something. Okay, no remainder. That's good. Okay, so the number of heartbeats per second, it is 1.5 beats per second. All right, and now I'm looking back at that point that I started out looking at, and I'm thinking, well, it does look like it's about 1.5, right? If 2 is here, I think that could be 1.5. All right, so I'm going to go ahead and accept this as my answer. 1.5 beats per second. This is one of your questions. Let's see if it was a quick check or I think it's a quick check problem. I didn't clip it here. All right, so you just have to keep an eye out for it. This one's definitely a quick check because look, it says item 5 and then it's got the multiple choice. Okay, so in this last problem here, we're going to decide if this relationship in the table is proportional. And the way I'm going to do that, okay, x, y. I'm going to make my fractions of y over x, okay, for each part of the table here. So I have 100 over 20. I'm going to simplify that, okay. I'm going to start by dividing by 10, gets rid of the 0. Then I'm going to divide by 2, and I'm getting 5 over 1. Okay, now I'll move on to the next one. Let's look at this one here. This would be 150 over 30. So you guys, if it's proportional, all these fractions will be equal. Okay, it will constantly equal the unit rate. What I'm doing here is trying to figure out if I have a constant of proportionality. So 15 divided by 3 is 5. 3 divided by 3 is 1. So far, so good. Those are a match, but I've got to keep going. So now I have 200 over 40. Okay, let's just cross out a 0 in both. That's the same as dividing by 10 in the numerator and denominator. Then I'm going to divide by their greatest common factor. Guys, all I'm doing is reducing these fractions or simplifying them. 20 divided by 4 is 5. 4 divided by 4 is 1. So these are all matching each other so far, but I've got 2 more to check. Yeah, you got to do all of them. Sometimes the last one will be the one that's the stinker. 300 over 60. Okay. Gonna divide by 10. Cross those out. I'm gonna divide by 6. And getting 5 over 1. 30 divided by 6 is 5. Alright, that one checks out. Let's do the last one. 400 over 80. Okay. Second number over the first number. Let me divide these by 10. Then I'll divide by 8. 40 divided by 8 is 5. Yay! They all match. So I'm going to say this relationship is proportional. They didn't ask me, but I could say that the constant of proportionality is 5. Okay? And what I would say here is that the unit rate is 5 calories per minute. And that's the amount of energy that this person is burning as they are walking. We could graph this too, and if we graphed it, it would make a nice straight line right through the origin. All right, guys, good luck.